Hello, welcome to another class with Ming. Today we talk about sets. What is set? Well, a set is basically a collection of items. These items can be anything. It can be a collection of all books in a library, for example, or the music CDs or MP3 music that you have in your laptop. It could be a collection of numbers or geometrical shapes. In this course, we'll be dealing only with a collection of numbers. For example, we can represent the set in many ways. One way to represent the set is, for example, I can say A is a set that contains, for example, 1, 2, 3, for example. And we can represent this graphically using maybe an enclosure. And then you put A here, and then 1, 2, 3. So these 1, 2, 3 are the members or elements of A. And we write that as 1, like E, an element of A, for example. So this is read as 1 is an element. So E for element, for example, element of A. Or it could be A1 is a member of A, for example. So in this case, so similarly, 2 is a member of A, and 3 is a member of A. And how do you write not a member of A? Well, we do it this way. If you want to say, let's say 4 is not a member of A because 4 is not within this enclosure, so you write E again like this with a slash. So 4 is not a member of A, for example, not a member of A, or not an element of A, not an element or not a member of A. So this is a presentation of A. Another way to represent A is to basically use something called a set notation. What is a set notation? Well, for example, I can write A as A, right, is written this way, 1, 2, 3. So this is using a set notation. This curly thing is represent a set. This curly thing represents a set. This means A is a set that contains element 1, 2, and 3. So elements 1, 2, and 3. So there are 3 elements in set A. So 1, 2, and 3 are the elements. And I also can write A as a condition, for example. X such that X is 1, 2, 3, for example. So this is in terms of conditions. So this is read as such as, right? Actually, the black one is not superior than the blue one because A is very simple, but it can be written, the condition, this condition notation can be useful when you are writing something like this. X such that X is a prime number, for example. Right? Or, example, right, I have another set B. B, for example, could be X such that X, right, is, right, and odd numbers, for example. It's an odd number, for example. So these are in terms of conditions. I can write it that way, in terms of condition. So here, this X here represents the variable of my input, of the input, and this is written as such as, and here is the condition for the set. So for the set, so it X has to satisfy this condition to be part of the a member. So in order to get membership to B, you have to satisfy this condition. So you say, you come along, I want to join B. Then they will ask you, are you an odd number? You know, if you are an odd number, you are